Before we get started on practice problem number 2, you just read the definitions of the point estimate and the margin of error. And so I wanted to try to make that a little bit clearer. So turns out we've already talked about the concept of the point estimate and the margin of error. We just didn't introduce that name yet. So back in practice problem number 1, the point estimate was actually that 54, the average from the sample of 50 cars. So the number that's at the center of our normal distribution, when we begin a confidence interval, we give that name the point estimate. Now, before we called this value mu, right? It was the population mean. A little bit of shift in thinking here. This average that's at the middle is actually x bar, which seems kind of strange. So in the past, it's been mu here, and then x bar was some other value outside. The difference here is everything we're doing in confidence intervals and with inferential statistics is based on just a sample. The idea is we don't know what the actual population mean is. We're trying to estimate it. And so we take a sample average and then we base this curve around the sample average. So even that kind of implies the name. If somebody said, hey, what's your best guess at the population average? Well, we'd say, well, you know what? From our sample, the average was 54. So if I had to guess just one single value for the population average, I would guess it's the same. I mean, that's what it was for my sample. That's my best guess at what it is for the population. Even though we know it's probably going to be something close to it, either a little above or below. So with the point estimate, it's our best estimate for the population average. And then the margin of error, well, we had two different margins of error for part A and part B. The margin of error is the distance from that point estimate to, in either direction, to where you make your lower bound and upper bound on your confidence interval. So in part A, the distance was 1.66. So we call that the margin of error. The error is at most, that much in either direction. And in part B, the margin of error was 2.19. Okay, so just some new names there, and we're going to be referring to that from now on in formulas. We're going to see it based around that. Speaking of which, we've got our margin of error formula right here. And yeah, this is how we're doing it, right? Z times sigma over the square root of n is how we calculated the distance, or now we're going to call it the margin of error. What's up with this alpha over 2? So this is kind of a notational thing, really, but some of you guys, I'm going to spend just like a minute explaining that, simply because some of you guys are going to take more statistics in the future. A lot of people, this is the only statistics course you'll need, and so it's really not a big issue if you understand the nuances of the notation and what this alpha over 2 is all about. But a few of you guys are gonna do more statistics, and so I don't want to leave you in the dark in that future class when everybody knows what this is and you don't. So what's up with the alpha over 2? Okay, so we talked about z sub alpha. There was a couple of examples back, and I forget how far back it was. I think it was just in chapter 6 when we introduced the z-score. We saw z sub alpha. So y over 2. Okay, here's where it comes from. Let's say in part A that we were just working on, we had a 95% confidence interval. The alpha is the part that's left over, like the complement. So it's that leftover 5%, or we might call it 0.05. If we were to divide that in 2, it would be 0.025, right, for the 95% confidence interval. So if we were to take that number and put it in the subscript, well, it'd be z sub 0.025. And if you remember the definition of when there's a number down here, what that means, it's the z-score with that probability above whatever, you're looking for the z-score that has this probability above that. And so there was a way that we could go about it. Actually, we did this very problem back in chapter 6. It was in the lecture z sub 0.025, and it turned out to be, I'll skip all the details and we don't have to go over that again, but it turned out to be 1.96. And that was exactly the z-score that we use here to go about calculating the distance, the margin of error. Okay, so just trying to be really, really brief about that. When we see these formulas in the future, in the lecture, in the typed lecture, you're going to see the sub alpha over 2. In the textbook, it does that. But when when we're doing the problems together, I'm just going to write z, or yeah, I'm not gonna use that alpha over 2. Okay, on that note, let's get to problem number 2, and let me just start off right here with part A. And I'm going to grab something else too. Okay, I'm getting all set up here. All right, so let's read it together. Practice 2, a survey of 30 adults found that the mean age of a person's primary vehicle is 5.6 years. Quite a few examples with cars and how old they are. So, okay, average age 5.6 years. Assume the population standard deviation is 0.8 years. What is the point estimate of the population mean is part A. So we know the point estimate is x bar. It's the sample average. Okay, so when we go back and read that problem again, it tells us a couple of numbers. A survey of 30 adults. The mean age of the primary vehicle is 5.6 years. Population standard deviation is 0.8. One of those is the point estimate. And say, okay, yeah, what does x bar mean again? It's the sample mean. Well, what's the sample mean here? And it's the 5.6. You might say 5.6 years, or you might just say 5.6. That's all they're asking for in part A, just trying to get us used to this definition of point estimate. Okay, let's go on to part B. Find the 90% confidence interval of the population mean, and we'll round that. Okay, the 90% confidence interval. So back in number 1, we did a 95% confidence interval and a 99% confidence interval. And now we're asked to do a 90% confidence interval. So it turns out these are the 3 most popular percentages for confidence intervals. 95%, really popular. The most popular is 95. 99 gets used a lot, and 90% gets used a lot. Okay, so let's see how this plays out. So here's what we're going to do. We're going to go to our normal calculator in StatCrunch. Okay, really the same procedure here as what we did back in number 1. Go to our normal calculator. It's going to look a little something like this. I didn't mention it before, but you notice in StatCrunch they always put a variable x there at the middle. Well, we know with the normal it should be a z. I don't know why they use x. They use x for everything. It should be a z. What they really mean is this. Okay, anyway, the point is we're going to use our calculator backwards, right? They want the 90% confidence interval. We're going to put 0.9, or you might put 0.90 in there for the answer. And hit compute. And you will get these 2 values as your lower z-score and upper z-score. Okay, but of course, just like before, we get the negative and the positive version. We're only going to take the positive version and put that into our formula for the distance, or the margin of error. So that z-score goes in right here. And now we can fill in the other parts, right? We know the standard deviation is 0.8. The sample size is 30 adults. And crunching those numbers and rounding to 2 decimal places, you get 0.24. Again, I really encourage you, go through and calculate that, crunch those numbers, make sure you get the same thing I do. I'm going to assume everybody's okay with that. Once we have the margin of error, we're going to go back to this formula now that was just introduced right before practice problem number 2. So we take our point estimate and we subtract the margin of error and we add the margin of error, and that's like calculating the distance above and the distance below. Now we have a more succinct way of going about these problems. So we found the point estimate was 5.6, and now we've got our margin of error. So if we add on the upper side, subtract on the lower side, here's our final answer to number 2, part B. The 90% confidence interval is 5.36, 5.84. To give the interpretation, we are 90% confident that the actual population average, population mean, falls somewhere between these two values. Our sample of 30 adults got us right in the center of this, 5.6, but we know that that's probably off by a little bit. So we found these two values, and now we can say we're 90% sure the real population average is somewhere in there. We have no idea what it is, and of course we're leaving 10% chance that it could be higher than this or lower than that. Okay. Hopefully now we've done this now for the 3rd time. You're kind of starting to get the groove for how these things work. So I think it's a good time to mix it up. In practice problem number 3, we're going to do just that. Let me read it. A researcher wants to know the mean IQ score for the population of first-year college students. Okay, maybe they're trying to see, do people get smarter by the time they get to the end of college? Yeah, that's what we hope, right? Assume the population standard deviation is 15 IQ points. All right. How many first-year students must be randomly selected if the researcher wants 95% confidence that the sample mean is within 3 IQ points of the population mean of all first-year college students? Okay, so they're definitely changing things up. Here's the thing. We're going to use our margin of error formula, and that's all we're going to need. I guess you could say we'll need our StatCrunch calculator too. This formula is the key. So in the end, they asked how many first-year students must be randomly selected. That is the sample size. How many students should we take in our sample? And from what else they describe, we are going to be able to get the values for the other 3 parts. And once we have all those values, we can go back and solve for n. So this is really a clever way to, kind of get what you're looking for, right? So this researcher, they know they want the 95% confidence interval. And they also are saying they want it to be within 3 IQ points. Okay, so let's see how this works, and we can reflect. So the goal is this. We know we're looking for n. That's going to be our things that we solve for in the end. So it must be that we know the other 3. So let's think that through. Let's start with sigma. What is sigma here? Of course, if we were in class, I'd just put it out to people. Maybe somebody would see it. And, well, usually sigma is the easiest one. It says right there, assume the population standard deviation is 15. IQ points. So we know that's going to be 15. Okay. How about the Z? Well, what is the Z here? Hey, the Z is based on the confidence level. So they said it's a 95% confidence. Okay. So what we could do is put that into our StatCrunch calculator, 0.95, have it work backwards. But you know what? We've already done that back in number 1, part A, and we actually kind of went back and saw that same number at the beginning of this video talking about margin of error. It's 1.96. So again, you could, hey, use your StatCrunch calculator if you don't remember that. Put in 0.95, have it work backwards. Here's the thing. Since the 95% confidence level, I'm telling you, it's the most popular one. It would probably save you some time if you just went and memorized, hey, a 95% confidence level means Z equals 1.96. And it may be helpful to remember, let's see, right, there's this one, and then I'm telling you the 99% is a pretty popular one. Let's just kind of write all these out. What was it for the 99? That was back in number 1, part B. Let's see, I'm kind of looking back myself. It was 1B, where are you? 2.5758. And we just did the 90%. In number 2, and it was 1.6449. So it may be that you just use these so much you end up remembering. I think the 1.96 is the easiest to remember, since these other ones have twice as many decimal places. That one just happens to round out really nice. Okay, in any case, we're going to see these z-scores quite a bit. Like just here, hey, 95%, boom, z equals 1.96. All right, finally, they tell us the margin of error. What is the margin of error in this situation? Well, there's only one other number left, right? It says in the question, find the 95% confidence that the sample mean is within 3 IQ points. So the within is like the key phrase there. Either in either direction, within 3, either adding or subtracting. Okay, perfect. So we can plug all this stuff in. And we're going to solve for n, and we'll know how many students this researcher should pick, which is pretty cool, pretty powerful tool. Multiple ways you can go about solving this. Perhaps you feel very comfortable solving this for n, then I say go for it. You probably don't need me to lead you through step by step, but maybe some folks out there would like some guidance. There's more than one way to go about this. What I would suggest, think of this 1.96 as being over 1, and just go ahead and multiply and multiply. And so the 1.96 times 15 gets you 29.4. Then I'm going to multiply the square root n over to the left. Then let's divide by 3. And it's looking a lot better. Finally, to cancel out the square root, let's square both sides. And here we get n equals 96.04. Now in a problem like this, n, right, it's your sample size. So we're talking about the number of students. So we probably are not going to answer 96.04. Let's go ahead and just say this researcher needs to pick 96 students. If they pick 96 students, then they're going to have what they want, 95% confidence that it's within 3 IQ points of the actual population mean for all first-year college students. And then that's really sweet. I mean, they can go out. Hey, I know exactly what my sample size needs to be. I'm going to talk to exactly 96 people, and that's pretty cool. That's pretty cool. Keep that in mind, maybe for your final project, if you choose to do a survey. All right, let's stop this video here. See you for the next set of practice problems. Go ahead and read the bit on the student T confidence interval, of course. See you there.